Hi everyone, welcome to Cloud on Air. My name's Jay Jenkins and I'm a customer engineer based in Singapore. Earlier today, Richard Coombs talked about where you should store your data. And if you missed it, don't worry, he'll be repeating it all again for you live in just a few hours. Prakhar Gautam is now going to take that and tell you once that data is stored, and with the variety and volume and velocity of data that you have, how do you actually make an actionable insight out of that? Prakhar Gautam is a customer engineer based in India, specializing in helping firms with big data processing and analytics. Remember that at any time during the session, you can ask a question below and we'll have technical experts standing by ready to help. So with that, let's fly you over to India.
Thanks, Jay. Hi, I will be talking about various big data cloud offerings in big data space. In the next 35 minutes or so, we'll be going through a high-level overview of the tools that we provide to run big data pipelines and data analytics in a completely no-ops Google managed environment. So let's get started. Before we get into what GCP offers, let's take a step back. Why is everybody talking about big data today? What really is the problem dealing with big data? It's hard. It's really hard to work with huge volumes of data and get the exact specifics you're looking for. So let's say you have amassed a lot of data over the years and now you want to navigate your way through. Where do you start? Data more often than not is present in silos. It's hard to consolidate all the data sources. You would need to develop big data pipelines, scale them, and make sure that all the moving parts are working together seamlessly. But again, it's very hard. How do I scale? How do I work with my pipelines in batch mode? What do I do if I need to go streaming? How do I mitigate failures? How do I add more resources and rebalance my existing resources? So Google also was no different. We also had to cope up with massive amounts of data due to our giant scale. Google services are truly global, as you can see on the screen, and we produce exabytes of data every year. A secret to Google's success stems from the fact that Google was able to operate at this scale before anyone else, and at a price point orders of magnitude cheaper than our competitors. So we started developing a lot of tools in-house. There was a lot of research which was going behind the scenes. Most of the tools that you see on the timelines have been in open research areas and have publicly available white papers. A lot of these internal tools were the inspiration behind a lot of open source and frameworks today. For example, you can see MapReduce. MapReduce motivated Hadoop. Bigtable research resulted in HBase. Dremel is now made available as BigQuery to our customers, and so on and so forth. But if you look at the timelines, then you will see that we've been working really hard over the years to better our underlying technology. I'll take an example of GFS, which was released in 2002. This was Google File System, and it was further enhanced to a planet-wide file system, which is called Colossus, and we released this in 2010. We stopped using MapReduce in-house long back in favor of Flume Java and Millwheel. We'll come back to this slide after we have run through multiple other offerings that Google provides to complete the entire circle. So now let's start warming up to the idea of big data. What are the stages one have to think through if you are trying to develop an application or a system that deals with big data? A simplistic approach would be to capture data at my source, process the data, store it somewhere, and analyze, and then start using it. Simple enough? Not really. Each of these layers come with their own set of challenges. Let's take a look at process and store stages, for example. So you can capture data from multiple sources. Once you have raw data, you would need to process it. And by that, I mean you would need to cleanse the data. Possibly you would want to reconcile your incoming data with your existing data sources and data models. And as part of your storage, you would want to make sure that your data is persisted for high availability and fault tolerance. And like all other things, you would want to enforce security on top of your data. Think of it as who would have access to what resources and at what levels. So this is a heavy slide, but I'll just try to summarize. Now, fortunately, we have been able to do a lot of hard grinds internally and have various offerings that can help you get through your big data problems. Most of the tools that you see on the screen, and we'll touch upon these in subsequent slides, have been used internally by Google over the last 15 years or so. Let's go through these stages one by one. During capture stage, data, as we discussed, can come from multiple data sources. It can be raw logs, it can be your analytics data, it can be data coming through pub/sub engines like Kafka, etc. Google Cloud Platform allows you to consolidate these disparate streams of data into one. So data thus captured then can be put through our ETL frameworks. Now you can start running batch or streaming processes on the fly. All you need to do is to set one Boolean flag as part of your code. This is what we call is data flow. And once you have processed your data, you basically have massaged your data, then you would want to run some analytics on top of it. This is where I would be touching upon our crown jewel, BigQuery. It's a petabyte scale data warehouse solution where you would just create tables, define schemas, throw a lot of data in, and off you go. You do not have to define any indices, you do not have to provision for any clusters, you do not have to worry about partitioning, sharding, blah, blah, blah. All of this complexity is handled behind the scenes for you. Again, as I said, this is a busy slide, so let me just jump over to a more simplistic slide for everybody's understanding. So, if you are aware of Lambda or Kappa architectures, you would relate to this picture, right? Data coming from multiple sources have to be consolidated, and then there is a batch layer, possibly there is a speeding layer, you consolidate the results and run some analytics on top of it. So there is a lot of complexity going on here. But on GCP, we make it a lot more simpler. You get the data, you clean it, you run your batch or streaming from a single framework, and then you run your analytics on top of it. Most of this without actually having to spin even a single virtual machine. So let's dive into data flow a little more. Again, this is a heavy slide, but I'll try to make the context simpler. Data flow, as I discussed earlier, can have bounded or unbounded data sources that you can see on the left-hand side. It comes with pre-built connectors with a lot of data, with a lot of sources. You can ingest data from pub/sub, from Kafka, from Google Cloud Storage, etc. Or if you can also build your custom sources for data flow to consume your data. Then on the middle, you see something what we call as data flow resource manager, which at the back end takes a look at the data that is coming in and the pipeline that you have designed. And then it intelligently figures out how many resources would you need to run the job. It also runs a close check on the instance health and summons auto healing of resources whenever there is a need. It also does intelligent load balancing among underlying instances to make sure that your job is achieving maximum parallel processing. You also see something called as watermarking, which is an important aspect of data flow, and I'll be touching upon it in subsequent slides. But let's just dive deep into a few of the things that I just breezed past. So let's take a look at what happens when you actually define a data flow job, right? Once your job is submitted, then we start deploying underlying workers to carry out tasks. So when I say underlying workers, I basically mean virtual machines. These deployments are fully managed and auto-configured. We constantly monitor instance health and start auto-healing, checkpointing, etc. in case of failure. So we do the heavy lifting, you just define how your pipeline should look like. Then, as part of this job execution, we internally create DAG, a directed acyclic graph, to better understand how parallel processing can be achieved and what kind of resources can be thrown at this problem. For example, when you define a pipeline, which stages of the job have to be executed in sequence versus what all can be processed in parallel. All of this intelligence is driven by the data flow model. This allows us to plan for the most optimized execution path and parallel resource management. Now, batch jobs are easier to predict, but streaming cases can be extremely tricky with a lot of complexities. What happens if you see a sudden spike as part of your request? How would you scale? No problem. You define your jobs to be auto-scaling as part of data flow, and we would move the resources up and down based on the load that you're experiencing. So on the slides, you would see that the number of resources are varying based on the request per second that the data flow is experiencing. Now, this is an extremely interesting feature of data flow. There can be times when the share of work allocated to a single node is much more as compared to other nodes. So while other nodes would have already completed their work, they would have to wait for other pending nodes to complete their work before moving on. And these blocking nodes actually create something called as stagglers. Your job execution will not proceed until and unless all nodes are free. Data flow has inbuilt intelligence to identify these stragglers. These stragglers are highlighted red in the diagram. We build a checkpoint and split up the work. Other idle instances take up this work and off we go. This would allow the jobs to finish much faster with much better utilization of resources. Now, it's actually worth remembering that in GCP, all the resources are charged by minute. So any minute you save on execution not only does wonders to your performance, but also saves a bunch of money. Just imagine that you're running a data flow cluster with hundreds of machines. Even a single minute saved for these execution time, you will be saving hundreds of dollars. Okay, now on to more interesting stuff that data flow can do. Let's imagine that you are running a job that requires you to group data by windows. For example, group all the data by hour or by day or by user sessions and whatnot. You get native support for this on data flow. It takes into account two important metrics to do windows: the time when the event actually happened, which is called the event time, and the time when the event was actually processed, which is called the processing time. Again, you can customize the same pipeline for batch as well as streaming by flip of a single Boolean flag in your code. Let's take a look at what I just mentioned as part of streaming. And this is again a heavy slide, so I'll just try to go slow on this. On the x-axis, you have plotted the event time, when the event actually happened. And on the y-axis, there is processing time, when the system saw the event coming through and some actions were taken on top of it. Now, let's say that you want to capture data in windows of every 2 minutes by processing time. So keep looking at your y-axis. On every 2 minutes, you would want to close a window and aggregate all the data that you already saw for that window. Data flow tracks the events coming in and heuristically figures out the delay between the actual event time and the processing time. Let me simplify this. So let's say there is a gap of 5 minutes between the event actually happening and the event actually getting processed. So if you define your window to be closed at, let's say, 12:02 p.m., data flow would expect all the data belonging to this window to come by 12:07 p.m., a delay of 5 minutes. All the data that comes before 12:07 is marked as early. But we are not living in an idle world. There is bound to be data that comes after 12:07, after the window has closed. What do you do with that data? All the data that comes after 12:07 is marked as late. Data flow persists a copy of the window data and allows you to manipulate it even after the window has closed. In our example, number 9 came way after the window was closed. Data flow can handle this without a problem. So all this support is actually baked in without you having to bother about keeping your pipelines open, aggregating, manipulating data, etc. All of this is taken care of behind the scenes. So how does a data flow pipeline look? This is how a pipeline looks. So this example basically emulates a game scenario where the pipeline is reading all the user scores from a source. In this case, let's say PubSub. So all the user scores, for example, are being captured through PubSub and then passed on to subsequent stages. You can define certain windows at which you would want to extract user scores. Yeah? Subsequent steps can run aggregations, for example, sum, averages, mean, etc. If you look closely at the numbers, fixed window stage is processing close to 2000 elements per second. And on the right hand side, you will see some more specifics. You can see that it's a streaming pipeline which has been running for about 20 hours now, and there are 3 workers provisioned by the data flow to run this job. All of this, again, has been defined programmatically, and you do not have to go and spin even a single virtual machine. The number of workers will, of course, go up and down based on the load of the streaming job and whether you have defined this job to be auto-scaling or not. Okay, on to BigQuery now. So what really is BigQuery? I hope a lot of you would have already had some experiences with BigQuery or at least heard of it. It's a petabyte scale data warehouse solution which is fully managed by Google. Right? It's completely no ops. Basically what this means is you create tables, load your data, it can go up to petabytes and just start firing your queries. That's as simple as that. So drawing a comparison between how does a typical data warehouse look against BigQuery. In a typical data warehouse, you basically spin up a cluster. Based on the volumes that you're experiencing, you have to resize your cluster. You have to shard the data. You have to replicate the data. You have to build for data resilience. You have to define indices and whatnot. Versus what happens in BigQuery is you define a table, you define your schema, you load the data, you fire your queries. That's it. So data query is extremely flexible in terms of consuming data from multiple sources. This is just a representation. We go much deeper than this, but I'll just keep this at an overview. So if you have data on Google Cloud Storage, great. We'll just read it from there. You can sync your data in BigQuery or run federated queries right out of Google Cloud Storage. You can stream the data directly into BigQuery too. Let's say you are working with data sources like AdWords or YouTube or analytics, etc. BigQuery plugs and plays with all of these data sources. There are a bunch of open source tools built by community that provides direct data ingestion points directly into BigQuery. For example, there is a connector out there in the open source which connects Kafka directly into BigQuery. We also have rich community of partners, few of them are listed here, that allow sync between their tools, for example, Informatica, Talent, Segment, to name a few, and we can use them to actually consume the data directly into BigQuery. So it's extremely flexible as far as ingestion and multiple data sources are concerned. Now, so you got the data inside BigQuery. What do you do with it, right? You can either start writing by your own queries, which are SQL based, or you can use some other tools if you're just looking at some sort of visualization, right? So BigQuery comes with plug and play capabilities with third-party tools like Tableau, Looker, Click, Google Cloud Studio, etc. So write your queries, run analytics, or if you're just looking for visualization, then plug and play with any other tools of your choices. So how does it look when you run some queries on BigQuery? For those of you who may not have actually seen BigQuery in action before, this is how it looks. You have tables loaded in BigQuery. You can import JSON, Avro, CSV datasets, and just start running your SQL queries. As I said, the tables can be of petabyte scale. And the important point here is we just charge based on the number of bytes that are actually processed as part of a query. So in this example, if you look deep, the query gets completed in 10.5 seconds, and we processed about 16 gigabytes. And this query actually run on a 100 terabyte Wikipedia dataset. But we'll only charge you for the 16 gigabytes that were actually processed. And first terabyte of data that is processed on BigQuery is absolutely free every month. So that's a lot of data for you to work with. We've had some really happy customers who have been extremely vocal about the benefits that they have reaped from BigQuery. Spotify team specifically have even taken to Twitter to express their excitement on BigQuery. In case one of these comments are not visible, I'll just read it out. So one of the customer goes on to say, Google's BigQuery is the bomb. I can start with 2.2 billion things and compute or summarize them down to 20,000 in less than 1 minute. That's the power of BigQuery that the customers can leverage. Okay, let's now start talking about bringing your existing workloads on GCP. So we talked about data flow, which is a new framework, which basically streamlines your stream as well as batch processes. And then we talked about BigQuery, which will help you to get your analytics going. But what happens if you are running, let's say, Hadoop or Spark or Pig or Hive jobs, right? That's where Dataproc comes into play. So Dataproc is Google's managed offering to run your existing workloads on, as I said, Hadoop, Spark, Pig, Hive, etc. Traditionally, how would you go about running a Hadoop job? You set up a Hadoop file system, have a Hadoop cluster up and running, and fire your jobs away, right? Even if I take all the complexity away from, let's say, a Hadoop cluster creation, management, etc., what happens to the resources if, let's say, you are not running a workload 24/7? So GCP takes a fundamentally different view of the problem. What if spinning up a cluster is just one of the steps of a Hadoop job provisioning? So Dataproc allows you to create an entire cluster in less than 90 seconds. Dataproc also comes built in with Google Cloud Storage Connector. So you can pretty much choose to replace your Hadoop file system with Google Cloud Storage. Now this takes away the complexity of storage management overhead, checking for file system, upgrading or rolling back to a previous version, etc. Also, when you shut down your Hadoop cluster, if you're running on HDFS, then you basically run the risk of losing your data. If you're using GCS, then you still have the data intact even when you spin down the cluster. So you basically define a job, and as a subsequent step in your job, you basically spin up a cluster in 90 seconds, do your job, shut the cluster down. As simple as that. So when you provision a job on Dataproc, you can basically choose to auto-scale resources from a case-to-case basis. Now you can create multiple clusters that cater to different jobs, and each job has different resource requirements. You can create a cluster only out of preemptible virtual machines. I mean, if you are aware of GCP world, there is something called as preemptible virtual machine, which is Google Cloud spare capacity that lives up to 24 hours. And those VMs are actually 80% cheaper than the cost of a standard VM. So think about a Hadoop job that you are actually running, let's say for 3 to 4 hours or even up to 10 hours. In those cases, you can start throwing a lot of preemptible virtual machines as part of your Dataproc cluster. You can save a bunch of money there and the performance stays the same. Or you can also start creating a cluster with custom virtual machines for that matter. So on the slide, you can actually see there is something called as custom 6 30720. So a lot of other cloud providers, they actually come with predefined specs in terms of vCPUs and RAM. In Google, we provide a flexibility to the customers to actually configure the right specs. So when I say custom 6, that I mean by that I mean you're running a VM which only runs 6 cores and 30 GB RAM. Right? So you can pretty much do those kind of customizations on your Hadoop cluster as well. So this is yet another example to showcase that you can create multiple clusters that cater to different jobs, and each job has different resource requirements. Right? So on the left-hand side, this is how your on-premise cluster would look like. Right? So the same cluster is sharing resources among 4 different jobs. Fast forward it to GCP on the right, each job can live on their own dedicated cluster with dedicated custom resources, because each job might have different requirements when it comes to underlying VMs, network, storage, etc. So just to wrap up, I would also like to touch upon an important aspect of Google Cloud. Right? So we are a big proponent of open source. And you would recall seeing this picture, and I promise that I'll come back to this in my subsequent slides. So again, Google has been working on these various technologies, and from time to time, we have released these as white papers. And we touched upon this earlier as well. So Bigtable powered HBase, Dremel, which we offer now as BigQuery, also motivated, for example, Apache Drill. Dataflow that we discussed at length is also being incubated as Apache Beam. So that is out there in the hands of community, and our motto is not to lock you into a particular cloud provider. You should be interoperable to move between multiple cloud providers. Borg, which is our dance master of our data center, so which orchestrates various resources inside data centers, pretty much is a motivation behind Kubernetes if you're looking to run your own containers. Furthermore, our latest open source, which is TensorFlow, is our machine learning platform that we have just recently open sourced. So just to round up, here is a quick mapping of open source products that are supported in Google Cloud. We've touched upon these quite a bit, but let's say you are looking to run Hadoop or Hive or Hue, Kafka, Oozie, Pig, etc., then you should start thinking in terms of Cloud Data Proc. If you are running HBase, then you should be looking at Cloud Bigtable. This is compatible with HBase API, so extremely compatible in terms of backward compatibilities. Cloud Dataflow, as I mentioned, is being incubated as Beam. If you are fond of Impala, then you should start looking at BigQuery minus all the overheads of management. Sentry pretty much maps to Cloud IAM, and Hadoop file system, you can pretty much do the same things minus all the management overheads on Google Cloud Storage. So that's the end of my presentation. So today we covered multiple offerings available under Google Cloud Data Umbrella, what you see on the left-hand side. There are a bunch of other offerings that I was not able to touch upon in today's session. That's hopefully for some other day. Apart from big data, as you can see on the screen, and this is just representative, there are some other extremely interesting cloud offerings that you can take a look at. There are webinars scheduled on SQL and NoSQL databases on GCP, as well as our API offerings in machine learning. So thank you for joining. For next steps, if you're looking for any kind of training material, then you can actually take a look at Quick Labs. This is a very recent acquisition on Google's part, or there are a bunch of material available on Coursera as well. If you're looking to get certified in any Google Cloud technologies, then the link is right there. So I will just invite one of my colleagues in the room and just give us 15 seconds or so. We'll try to pull out some Q&A from the questions that we are getting from the audiences, and we'll jump right into the questions. Just give us 15-20 minutes to be back. Thank you.
Yeah. Thank you, Prakhar. Thank you very much for that insightful session. I really enjoyed it. So I've put together some questions from the that have come through from our viewers.
Sure.
So let's go through them and discuss.
Absolutely.
Absolutely. Yeah. Good. So there are a couple of questions around how do we compare against AWS,
Sure,
or any other products out there.
Sure.
I know that we have been working on these technologies for the past 10 years. So obviously, some of the products are much more mature than that you get in the market.
Sure.
And I think the integration is better. But what do you think? What do you think it distinguishes completely from
sure.
others?
I mean, that's a great question and extremely commonly asked question as well. So how we are differentiated from any other cloud vendor is actually the simplicity of it, right? So when I was talking through Dataflow, BigQuery, etc., we basically take away all the underlying complexities, right? So unlike any other cloud vendor, you do not have to provision even a single machine, for example, to get your BigQuery going, right? So if you have some data sources, you can just start putting data inside BigQuery, and you just start writing your SQL queries, and you do not even have to define indices, right? So we do all the heavy lifting behind the scenes. Another big advantage that Google brings to the fore, and this is not only specific to big data, but generally in other resources also, is how do we bill the customers, right? So BigQuery again is charged based on the number of bytes that are being crunched, or for example, Dataflow sources or data proc resources, etc. We only charge them by minutes, not hours. So there are performance benefits to be had, as well as there are commercial benefits to be had.
Fantastic. And my personal favorite is obviously, the way it integrates with the rest of the products and stack and GCP services.
Yeah, absolutely. I mean, that's a fair point. So even in data flow, right? So I talked about multiple ingestion points. But let's say you're dealing with something which is completely proprietary. You can start building your own custom sources and sinks, right? So we are basically not locking you in. And as I mentioned, we are huge proponents of open source. So data flow right now is being incubated as Beam. So it's out there in community's hands and people are doing all sorts of things. So we're not locking you in our cloud platform. You are happy to move around, but if you choose to run on us, then basically we'll take care of the resources underlying.
Brilliant, brilliant. So a few of our viewers would also like to know about how did this tie up into Google Analytics? So basically, a lot of customers out there use Google Analytics for their marketing campaigns, and then they're saying, how do they take the data out of that, and how do you put it into any of the big data tools, and how do you process? So I know it's easily done. I mean, we offer integrations as well, but what do you have to say? I mean, is there a use case that you can draw around this?
Sure. So again, I'll go back to the same point. It's very simple. Google Analytics, let's say somebody is running Google Analytics Premium, then you get plug and play support on BigQuery, right? So all the data that you see in GAP gets directly transferred into BigQuery without a problem. We'll also provide you credit, financial credit. So I think it's $300 per month. So if you're a GAP customer, then you get $300 of credit on BigQuery, and you can pretty much start exporting your data on the fly. Plugs and plays, start running your queries, and off you go. So that again ties back to question 1, where how seamless is the data movement behind these multiple sources of data?
Perfect, perfect. And even if it's a free version, you could still export and import. It's pretty much easy that way.
Again, talking about BigQuery, right? So you have data in Google Sheets, you have data in
Excel
CSV,
sheets, any
Excel
format,
sheets, any format, JSON, etc. Anything is fine. So we're pretty flexible there.
It's simple. You just upload and run your query.
Absolutely.
Simple as that. Brilliant. So there were a few questions around how big data being enterprise centric. I mean, is it only limited to enterprises or other corporations as well? I think anybody who's accumulating data can use it, whether you're a small organization or not. What do you think? Is there anything that you could?
Yeah, I don't think we are actually segregating it by the class of users, if you will. But at the same time, we are actually looking at providing the right kind of security controls, irrespective whether it's an enterprise or a smaller organization, right? So IAMs, which I talked about, the access management policies, etc., you can pretty much define on a resource level. And so think about it: who has access on what resource and at what level. So all the offerings that I talked about have the same kind of footprint, right? So for example, I'll take an example of BigQuery dataset. So who has access on a table? So do they have a view access? Do they have a delete access? Do they have a create access? So you can define all of that as part of your definition of datasets, tables, etc. And again, this is built with enterprises in mind, but is absolutely available to all the customers out there. So I mean, we're not differentiating, but we're building the right kind of things that can be extended from enterprises to SMBs to startups.
Cool, cool. And also, if you look at the small enterprises, especially, they don't think that they accumulate a lot of data, but some of them really do. So if you're running a marketing campaign, we just talked about analytics, all of the data you could move to big data and run it and
absolutely.
do it.
I mean, even if you're accumulating, let's say 10 gigs of data, right, which may not be huge from a BigQuery's point of view. Why do you have to get into complexities of creating? Absolutely. So no disk management. How do you shard the data? How do you make sure that this is fault tolerant, etc.? Leave the complexities to us. We can take care of it.
And then you're charged accordingly, so you don't have to worry about. I think the biggest strength for the SMBs is that this. Like enterprises, they might not be able to invest too much into building their own infrastructure. When you come to BigQuery, all you have to do is bring your data and then we run it for you. Don't worry. I mean, it's much more cheaper. You're not locked into capital investment. To be honest, I think that's the key for me, if I'm a SMB, to be honest. So there was also a question around asking, how easy or difficult it is to upload or ingest trillions of rows of data. Which product is probably good for us, and then whether it's going to be cheaper or easier to run queries, or do we have to provision infrastructure for that or not? I know BigQuery is the answer. We want to talk through what would they have to probably do to make it easier, simpler.
Sure.
Yeah.
And I'll go back to the Spotify comment on Twitter. So they were ingesting 2.2 billion row tables, and there were multiple such tables, right? So they were able to do this without a problem. There are multiple customers who actually run petabyte scale of tables on BigQuery without even telling us. That's not a good practice, so please talk to us if you're running petabytes. But yeah, they can pretty much start spinning bunch of resources, define the schema, load the tables, and off you go. And we have actually made data ingestion extremely simpler. So for example, if let's say you are running your stuff on AWS, we provide something called as transfer services, right? So basically peer AWS with GCP, and you can have your data seamlessly synchronized from AWS to GCP. And once your data is in GCP, then you basically can get it in BigQuery, Dataflow, Dataproc, or any other big data offering. So it's really, really ridiculously simple.
Perfect. And I know you just discussed at a high level about the payment and charges around billing around BigQuery. If you could dig a little bit deeper into that and say how the charging is around.
So charging, this is a common question.
Yeah.
So BigQuery charges based on two things, right? So one is storage, and one is how much data that is being processed.
Yeah.
So every terabyte, as I mentioned, every month is absolutely free of cost. And after that, if you are running a terabyte, so basically if you're processing terabyte of data, we'll just charge you $5 every terabyte. There are multiple things that you can do to make sure that your data you're not scanning the entire tables every time. So basically you put right where filters, there is something called as table decorators, which will allow you to partition your data. So terabyte of data is still a lot in terms of bytes getting processed. But even if you hit those limits, we just charge you $5. If you are a customer who runs a lot of ad hoc queries, who's not really sure of how much will your querying cost will be, then we also come out with flat pricing. Right? So you basically talk to us, and then we basically define you in a certain bucket. That's fixed price, and then you basically start running your queries without worrying about how much data processing will happen as part of your query crunching.
Yeah, and the visualization software that goes along with it, Data Studio is free to use, which I really love about that. And if not, bring your own data visualization software and then integrate with that. And that's
so we just came out with Data Studio, which is now free of cost, plugs and plays with BigQuery, and you can pretty much define how your visualization and reports will look like. It generates SQL queries at the back end, and plugs and plays very well with BigQuery. So if I draw a picture, your BigQuery consumes data from a lot of sources, YouTube Analytics, Kafka, blah blah blah, and then it is in BigQuery, and then you run your visualization layers on top of it, and then run SQL queries on top of BigQuery.
Cool. So, and the other day I was speaking to one of our customers, and they were asking, is there a way I can use BigQuery with the IoT devices that's deployed for themselves? Is there a way to stream? I know we have talked about it at a high level. I know it's possible. So, would you want to maybe touch at a high level how you could do integration of IoT into the BigQuery as well?
With IoT, you have data coming from multiple sources, right?
Of course, yeah.
Now, there is something called as PubSub, and my apologies, I was not able to touch upon this. PubSub is publisher-subscriber.
Amazing tool, by the way.
Amazing tool. So, if you live in Kafka world, you should definitely look at PubSub. So, data streams coming from multiple sources gets plugged and played into PubSub. And then from PubSub, if let's say you want to run some ETLs on top of it, right? So, some data massaging, normalizing, etc., then you put it in Dataflow. It can do batching, it can do streaming. Remember, one flip, Boolean flag. Once you have the data normalized, processed, you basically start putting it in BigQuery, right? So from your end sources to BigQuery and then visualization, again, absolutely zero need to create even a single virtual machine.
Perfect, perfect. And yeah, there was also a question around how do you transform the data, and I think you just answered that in your previous answer. So I think we're almost done in terms of the questions that we've got. Okay. And if there are any questions, if we have not answered, we will answer them on the web page. So please do check them out.
All right. Thank you so much.
Thank you very much. Thank you very much for your time.